Let's move on to the next question. The diagram shows the curve y equal to x cubed minus 6x squared plus 9x, okay, given to you for x more than 0. Okay, the curve has a maximum point at A and a minimum point at B, which is on the x-axis. Now we know on the x-axis the value of y should be 0. Okay, now what else? The normal to the curve at C, right here, the point 2, 2 means the normal to the curve at B, at the point D right here. Okay, now we have to find the points A and B. So let's find those 2 points. Now as we can see, the point A and B are the stationary points, so we know that at stationary points, which is the maximum and the minimum points, we know dy by dx have to be 0. So let's find dy by dx. That will be 3x squared minus 12x plus 9 have to be 0. Now we can simplify. Let's divide by 3 everywhere. You will have x squared minus 4x plus 3, that have to be 0. Now we can factorize, obviously. That will be x here, x, 3 is 3 times 1. We need minus 4, that have to be minus 3 minus 1. X will have to be 3, x have to be 1. Now, for this value of x, let's find the value of y. Replace back in the equation you will have. So 3 squared is 9 minus 6 times, 3 cubed. 3 cubed is 27 minus 6 times 9 plus 9 times 3. That should be 0 because it is this point right here, right? The point B is 3, 0. This is for the point A, 1 minus 6 plus 9 should be the value of 4. So y will be the value of 4 over here. The point A should be 1, 4. Okay, so now we have the point A and B. Great. Now part 2, we have to find the equation of the normal to the curve at C. Okay, so we know the point C is the point 2, 2. To find the equation of a normal, again, normal is a straight line. To find the equation of a straight line, we must find the gradient of the normal. But now we understand, to find the gradient of normal, we first have to find the gradient of tangent, because we have dy by dx. So tangent is simply, or gradient of tangent is simply dy by dx. So dy by dx at the point C, where x equal to 2. Let's see, what do we have? Replace, this is dy by dx, 3 times 2 squared minus 12 times 2 plus 9. That should be minus 3. That should be minus 3 as my value of dy by dx. Okay, great. So what else do we need to have? From this, I can conclude that the gradient of normal have to be 1 over 3. Because tangent and normal, they are at 90 degrees to each other, or they are perpendicular to each other. Because of that, we can derive this. Okay? So again, if you guys don't know, let me write this down for you again, because I get this question all the time. Why is this like this? Because they are perpendicular. Always remember, tangents and normal, they are perpendicular to each other. Because of that, I can say the gradient of tangent multiplied by the gradient of normal have to be minus 1. So here we have to use this to find the gradient of normal. We have the gradient, we have the passing point 2, 2, x and y value. We can find the equation of the normal. So y minus 2 over x minus 2 has to be 1 over 3. Cross multiply, you will have 3y minus 6 is equal to x minus 2. 3y will be x minus 2 plus 6 should be plus 4. So this is your equation of the normal at the point C. Again, you can simplify, make y become subject. It is up to you. Now for this one, we have to find the area of the shaded region. Okay, so before we do this, actually, how about we find the point D? Now we know that the point D, the line DC, the line BD is vertically upwards, as we can see here. We know the x value of D will have to be the same as B, which is 3. So what is the y value? Let's find out. Replace the value of x in this equation here to find the value of y. So CD was found to be 3y equal to x plus 4. Now for the point D, we know the value of y, which is 3. Sorry, x, which is 3. We have to find the value of y. Replace, you will have 3y has to be 3 plus 4. So y has to be 7 divided by 3. 2 1/3. Okay, that is my value of y for my point D. Again, let me show you guys why this is helpful. For example, here I know now the height here is what? The height of this is 2 1/3. And here I can draw this line. What is the width of this? So the point C was found to be 2 2. This is 2 here, right? 2 2. And again, this is the height 2 over here. And the point B was 3. Right. Now we know all these values now. We can definitely use that somewhere to find something that we need. Now to find the area of the region, so by observation, step by step, what can we see? So we need this area, right? So to find this area, we must first find the area of the whole thing, right? And then minus the area that we don't need, which is area under curve. That makes sense. So number 1, area of the whole thing is what? So by observation, let me take it out for you. It is this is vertical, and this is like this. This is the value of 1. This is 2. This is 2 1/3. It is area of a trapezium, obviously. So area of a trapezium is half times sum of the parallel side, that should be 4 1/3, and times the length in between, that should be times 1. So half times 4, this times 1, that should be 2 1/6. This is the area of the whole thing. So now we have to minus area under curve that we don't need, right? And this is done by using integration. Area under curve is done by integration between the limits of, this is 3, this is 2, so 3 to 2. Y is given to you by x cubed minus 6x squared plus 9x respect to dx. That should be x power 4 divided by 4 minus 2x cubed plus 4.5 x squared between 3 and 2. Now simplify. 3 power 4 is 81 divided by 4, that should be, first is 20.25, then we have minus 2 times 3 power 3, 2 times 3 power 3 should be 54, and here we have 4.5 times 9, that should be plus 40.5. So minus, now for 2 power 4 is 16 divided by 4, that should be 4, minus 2 times 2 power 3, that should be 16, plus 4.5 times 4, that should be 18. So simplify here and here, you will have 20.25 minus 54 plus 40.5, that should be 6.75, and minus 4 minus 16 plus 18, that should be 6. You have 0.75. So the area that we do not want here below the curve is 0.75. So finally, the area that we want, it is 2 1/6 minus 0.75. So 2 1/6 minus, answer should be 2 1/6 minus 0.75 should be 1/5/12. If you want to, 17/12 units square for the area value. And that will be a question. It's pretty interesting, but as you can see, anything we can be done step by step and by observation.